Hello. Let's solve this problem. Let me read the problem. So a charge of 6.5 microcoulombs is placed 4.4 centimeter from a second charge. If the force between the charges is 5.4, what is the magnitude of the second charge in microcoulombs? In other words, measured. The unit should be microcoulombs. Okay, so usually what I do, I just draw in the left side whatever are known. So Q1 equals 6.5 microcoulombs, R, which is distance between these two charges, 4.4 centimeter, and the force 5.4. Note here, there is a problem. 5.4. It says 5.4. The problem saying that the force between the charges is 5.4. So here is a big problem. The problem is that 5.4 what? Newton, kilonewton, or what? So if we don't know what is unit of the force, this problem, of course, cannot be solved. Now, in this case, I highly recommend whoever gives this problem, you contact with them, your teacher or your tutor or whoever. So ask what is the unit of the force, because you cannot solve this problem. Anyway, but assuming right now that the unit of this force is given like a Newton, let's assuming. And let's solve the problem. So what we have to find? We have to find charge, second charge measured in microcoulombs. So in order to solve this problem, it's very easy. You just need to know Coulomb's law, what Coulomb's law is all about. That if you have charges, let's say Q1, Q2, a distance between these two charges R, then the force acting on each charge will equal, of course, this is absolute value, the force, equal Coulomb's constant multiply charge 1 to charge 2 divided all this the r square. Again, r is the distance between these two charges. Now from this equation, what you have to find, we have to find q2. This is just a simple math here, right? So what it will be f times r square divided k q1. We also have to include in this section that our Coulomb's constant is equal 8.9, let me see, 8.988 times 10 to power 9 Newton multiply meter square divided Coulomb's square. Okay, so now let's plug the numbers. So F, again, we assume that it is with Newton. So it will be 5.4 Newton. I'll tell you why I'm putting units. You will understand later. Multiply R square. So R, note that R is not in system of international unit, right? So we have to convert it. So in SI system, the unit will be meter. So 4.4 centimeter. Of course, it equal 4.4 times 10 minus 2 meter. And then we plug here, it will be 4.4 multiply 10 minus 2 meter. All these squared, right? And divided. Coulomb's constant 8.988 multiply 10 negative 9 units Newton meter square divided Coulomb square multiply charge 1, which is 6.5 microcoulombs. Again, this is not in SI system. You have to convert to SI system, which will be Coulomb. So it will be multiplied 10 minus 6 coulombs, because micro is 10 minus 6 just, right? Okay, what we will have now, these units. Let's pay attention to the units. These columns will be, this is gone, right? This meter will be squared when we open this parenthesis. This will go from here, right? And then this Newton will be gone with this one. So this column will go to nominator. So your answer will be with columns, whatever we get. So my calculation showed that it is equal 1.79 times 10 to power negative 7 columns. But remember that question is you have to present the charge in microcolumns. So in microcolumns, it means we know that 1 microcoulomb equal 10 minus 6 coulombs. So in order this present as a microcoulomb, if you don't get or some problem, so what we can do, we can just write 1.79 multiply 10 minus 6. So this is already micro, right? So what else we have to do in order to keep my 10 minus 7? We have to multiply 10 minus 1. So this is still Coulomb, right? The unit. So since this is already micro, so if you multiply this to this, what you will have? You will have 0.179 micro Coulomb. So this will be your answer if you did everything correct. Anyway, but the whole point here is that the problem, there was a problem in this question, in this, because the unit of the force was not given. You cannot solve. But we assume that it's in Newton, and we just did calculation. We got this number. Okay, thank you so much. Have a great day.